So let me see. I'm going to share my screen, and you'll see a bunch of stuff on my screen because I've been playing around with some things, and I want to highlight like a few examples of things that we're going to do today. So the first thing is reminding you about like installing, R and R Studio and where to get them. I'm not going to run through the whole process, but just reminding you that there are two elements to this. There's this program called R Studio, which puts all of these bits together. And if you remember, we've got like our scripts up here. This is our R console down the bottom left. So when you download R, this is what R itself is. And all of this is stuff around R essentially, which RStudio keeps together. Top right is our environment up here. And there's a few things I didn't necessarily show you last time. So things like a history of all the commands that have been run here and everything, which is handy if you want to go back or have a record of what you've done. And there's a few other things up here, like including a tutorial on how to learn to use R and things too, which is not a bad place to start. But the environment is mostly what we want to see, and these are things that are currently, available to us, things that we could call on with other commands. Bottom right is things like, here are the files that I've got in my working directory. Here is a current plot that I've got going. Things like the packages that I've got installed. I've got lots, and we're going to install a couple of more new ones today. What else? We've got help files and a few other bits and pieces here. So that's just a very quick reminder about what R is and RStudio is and how it all works. Now, the other thing to remember is that these scripts up here, so here's a script that we're going to start with, and this is actually one of the scripts that we were playing around with last week, are the way, like the idea of these scripts is we could type all of these commands individually into this console down the bottom here if we wanted to, but that way madness lies. This allows you to keep track of things and easily go back and run things and make notes and everything. Mind you, this is how people used to do stuff, which is a little bit crazy. So the idea here, remember with these scripts, we finished last week by talking about some best practice in terms of the way these scripts might work. One of the most important things is always to start a script with clearing your environment here, which is, so let me see, where's the chat? I will go into the chat and I will drop commands into the chat so that you can sort of make these scripts if you like as well. So the first thing that we usually put into a script is this rm list equals ls thing. And the point of this is when I run this, so remember, if you want to run something out of your script, you select it and hit the run thing and watch what happens with my environment over here. That goes away. Okay, my history is still there. So, if I wanted to go back, I could get it. But that clears everything out. So it clears out any variables or analyses or anything like, or even data that I've got available to me so far. So to start off, we're going to be using the mtcars data set again. So this is this built-in data set with a whole bunch of car variables. Again, I'll drop some code here in the chat. So this is assuming that you have some packages installed from last time, which is hmisc, dplyr, and reshape2. And if you don't, there are these install packages commands up here. And at the moment, these are commented out. Remember, we can write comments to ourselves in the script with a little hash in front of it. And if you want to get rid of that hash, we can select all of this and do Command Shift C to get rid of that initial hash if we want to. But we don't, if we've already got the packages installed, we don't want to install them every time we run our script because it'll just slow everything down and it's an unnecessary step. So you only need to install a package once, or if you need to update it. Otherwise, you just use the library command to load them. All right, so we use data mtcars to load it. And then we've got these ones here, the library commands that we run. And now we've got our mtcars dataset open here, 32 observations with 11 variables in there. So 11 columns of data for 32 different car types. Okay, so that's what we're going to be using today. Now, before I go on any further, have I lost anyone yet? I'm hoping this is all just like quick crash course revision from last time. Everyone okay? Good, good, good. Now, of course, one thing here is I'm dealing with built-in data sets. And of course, very often you'll be loading your own data sets instead. It's not too hard to do that. And I've touched on that a little bit previously. But you'll find heaps and heaps of scripts on how to do this. So I'm not going to touch on it today because I just want to use some built-in data, easy stuff to play with. If I have time later, I'll get into that. All right. So if you remember as well, we had some commands that we used to just get a sense of our data. So we can always just double click on, I'm going to close everything else I've got to open up here just so it's not confusing because I've got a few scripts that I prepared for today. So we can double click on MTCars and this will actually open up and I can see my data here. And this is all right when you've only got like a pretty small data set like this, like 32 rows of data and 11 columns. That's nothing too bad. But when you deal with the kind of data sets that I often do with tens of thousands or hundreds of thousands of data points in there, visually looking at data like this is a bit crazy. So we can use commands like head, H-E-A-D, MTCars, and this will show you like the first 6 rows of your data as well, which is a handy little way to get a sense of what's going on in your data there. All right, we did some stuff on like making a correlation matrix and looking at things like p-values and extracting those. We'll do a bit more on that in a second. Actually, let's do it now. So if we have a right down the bottom here, forget all this correlation stuff. We have this command down the bottom, which again, I will drop into chat. And there's a few components of this. So remember, this is a t-test that we're doing. The command, the function that we're doing here is a t.test function. And remember, R is case sensitive. So it's all got to be lowercase unless it's like a variable has a capital or something in it. And the formula for whenever we run an analysis is our dependent variable here, which is MPEG. A t-test requires a continuous dV. So MPEG is miles per gallon, which is a continuous thing, and then a tilde, and then an IV. And because this VS thing is stored as numbers, we need to make it into a factor. And again, this is all stuff that we touched on last time. We can recall this if we would like to. Okay. So I can, as in I can do a factor within the middle of a command here if I would like to. So I'll do that and I will run it and then I can actually just, so this creates a little thing in my environment called t-test results up here. Okay. And I can just call on this to see what it contains. Like at the moment, this command has just created a thing called t-test results. It hasn't actually shown me the results of the t-test because they're stored in this object. So to have a look at it, I can just type, what does this look like? And here it is. Here's a t-value, degrees of freedom, and a p-value, as well as a confidence interval and means and things like that. So the reason I'm showing you this again is because we can look at things within the t-test as well. So we can go, and we're going to use this in a little bit. So I can do t-test underscore results and then do a $sign and do something like p-value. Like if I just want to recall just the p-value, I can do this. And here is my p-value. Now, this is really cool because what I'm going to show you to start off with now is how we can actually use R to write documents that draw on our actual results so that we don't necessarily have to copy and paste results into R. Or even the worst thing that we can do is like hand type them and stuff because, it's very, very easy to make mistakes in doing so. So to do this, I'm going to show you a thing called R Markdown. And then I will copy and paste some code again into the chat for you to play with. But I'm going to introduce you to the idea of R Markdown, which is a document format. And this allows us to format documents in terms of whatever formatting we like if we're using APA formatting or Harvard or Chicago or whatever, and to actually call on live the data in from R, like in analyses and things like that too. So let me show you how this works. previously, we've just been dealing with scripts here, right? And remember, this is glowing. My name of my script is red with a little asterisk next to it because there's something in there that is unsaved. So whenever you see that, just think, did I change something? Do I want to save it? Probably do. So I'll just save that before I move on. So what we're going to do now is we're going to go to File and New File, and we're going to go to this thing called R Markdown. Now, I really like the potential of R Markdown here. It's one of those things where it might take a little while to get used to. But once you get used to it, it's the kind of thing that allows you to make far fewer mistakes with reporting results and things like that, and also potentially facilitates working with collaborators a bit more. So we're going to do an R Markdown document, and this screen will pop up. And we can enter some stuff into this. So we'll say, all right, let's give this document a title. What's my title of my document going to be? I'll call this something like, demo of using R Markdown. Okay, you can call it whatever you want. And then describe what you're going to, like how you want the output. Do you want it as an HTML document? Do you want it as a PDF or a Word document? I'm going to use Word here. If you do want to use PDF, you have to install some additional stuff. So I'm just going to use Word for now. All right, so I'll do OK. And what pops up is this document, which actually shows a bunch of demo of how R Markdown works. Like by default, it will give you some chunks here that you can play around with. We're going to take this in a minute and turn it into a document that actually draws on some results. Okay. So the top stuff up the top here, this is some header information, and there is the title that we put in. There is the author name, and of course you can adjust all of this as you would like. There is, it's going to pull out the system date and put that at the top of the document. And the output here, I asked for a Word document. All right. Now, this code, there's a bunch of stuff that's going on here. You can see there's some code here, for example, that's like got this sort of, I don't know, beige kind of color behind it here. Is it a beige? I'm a guy. I see like 3 colors. And there are these like 3 kind of inverted like commas. They're not quite inverted commas, but these things, these are code chunks. So you can actually run these, like run code, run analyses in your document, right? And then draw on those results and actually extract that into your document. Then this is how you do things like headings. And I'm going to show you what this all looks like in a moment, like in an actual Word document, but I'm just talking through what the code is for you. Okay. And it tells you how to do anything with it. I'll show you that in a sec. So here's an example. We're going to do some actual R code here. We're going to do a summary of the cars data set, which is similar to MT cars. We can also include a plot here if we want. And here's a little important thing, this echo equals false thing. I'll show you what that means in a sec too. Okay, so that's my document all set up. Let's have a look at just what this looks like when it comes out. And then we'll do a version of an R Markdown document where we'll actually play around with it and extract some stuff out of analyses to show you the idea of how this works. Okay. So once you've got all this set up, we'll just do a quick save here as well. So you want to save it and give it a name. Like let's call this, demo. I think I've already got a few demos, so I'm going to have to call it something new. Markdown 2 or live or whatever. This is the one that I did live. All right. So this is saved here. It appears as a document over here, which means that I can always open it up just like a script and go back into it and edit it. It's just a special type of script that allows for certain things. All right. Now, I don't need to select all of this and press run. What I do, there's a command up here, which is knit. I don't like, there's a reason it's called knit, but it's like really nerd humor, so I'm not going to go into it. So we just run this knit thing, and what you'll find is a document opens up. It tries to run all of this stuff, and here's my document. This is a document that's created from what I just made, right? All of that code. So you can see here's my title. All right, the title up the top there, all right, that I put up in my XML thing. Here's my name, here's my date, all right. And it's even done it in the year, month, day thing, not that weird American like month, day, year thing that they seem to love. Here's a title, like R Markdown here. Here's the code that I've got. And then I've got this summary thing that I asked for, the summary of cars here. And here's how it's come out. It's actually given me some output in the Word document. I might even turn off those paragraph marks to clear it up a little bit. But that's like your standard basic R output. But this output could be whatever you like. And so we're going to talk today about, how to make output look prettier and things. So I showed you some basic box plots and histograms and things like that. We're going to talk particularly about ggplot2 today with some demos of some cool looking graphs to give you a sense of what figures can look like. So, here's some output that's come out, but like this doesn't look very, what you would expect in like an academic article, right? And in particular, we're showing the commands and we don't necessarily want to show the commands. So here's my plot. That's looking a bit better, all right, a bit more academic-y. And notice as well that I don't actually see this command, this plot pressure thing anywhere because it's this echo equals false thing. All right, so I pop that in a little block of code and then my code doesn't come through. So that's the concept of R Markdown, right? I can actually run the analyses within my document. I don't have to, and then share this Word document with somebody. And while we're working it all out, if I'm working with someone who's a bit statistically savvy, I can show all the code so that they can have a look through it all in one document rather than having to share like your SPSS output or even your R output and scripts and all that kind of thing. It's all here in one document. All right. So this is a handy thing about R Markdown. So let's have a look at what else we can do with R Markdown to make it work a little better for us. All right. We're going to take this and we're going to use some of the things that we've learned in R so far to make this better for us. Okay. So what I'm going to do now is I'm going to share some code with you again. I'll show you what it looks like first. This is a different document that I've been working on, and this is using the MTCars dataset. In this case, I'm doing a t-test, and then out of the t-test, I'm extracting the degrees of freedom, the parameter here. I'm extracting the statistic, the t-value, and I'm also extracting the p-value, and I'm doing some rounding here as well, like I'm rounding it to 3 decimal places, right? And this is going to appear in my text so that I don't have to type all this in. It comes straight from the output. All right. It's also going to pull out the means of each of the groups here too by using some of those things that we've seen before, like filtering, for example, or subsetting. Okay. So that's the concept that we can do in R Markdown. I'm going to run this and show you the final output, and then I will copy the code over so that you see what this looks like, what we're aiming for. And then I'll copy the code over it, and I'd love you to have a go at it. Okay. So I will knit this and I will get a new Word document. All right. And I forgot to put my name in the top. And here I've formatted the month a little bit differently, like, month, day, year, just to show you that you can. Here's my introduction. And of course, if this was a real paper, I would have a lot more typing in here. And we'll talk about formatting, like APA formatting and referencing and stuff in a sec too, and how we can deal with references. Here's my methods heading. So see methods here has a hash ahead of it. And so you put like number of hashes depending on what level heading you are aiming for. Here's my MTCars data set. At the moment, I am showing the code, but so I might share this for the t-test. So I might share this with like a collaborator, for example, just for full disclosure. Or I might even make this available, like if I was sharing this as a preprint in the interest of open science, for example. But of course, I can make this disappear by typing echo equals false. And here's my output. An independent samples t-test, probably call it, revealed a significant difference in miles per gallon between cars with automatic and manual transmissions. Here's my degrees of freedom. Here's my t-value. And here's a p-value. Now, at the moment, this is saying p equals 0.001. I'm pretty sure it's p less than 0.001. So I'll adjust that there in my code. And I will try and knit again. And I'm going to point to something here. Notice it hasn't updated because I've still got the same document open. So every time I knit, I close the document, I knit, and now it's updated with a less than here. Okay, so that you just got to remember to close your document before you knit each time. All right, so let's have a look at this script here and how to pull out these pieces of information and put them in a document. And notice here as well, here are the means. Ideally, you would include like standard deviations next to them as well. But this is just a demo, just highlighting how it all works. Okay. So first up, before we go any further, can you see the value in doing this? Or do you have any questions before we start getting into the code? Is it all right? Maybe?
I have just a quick question. Would this kind of document be something that you would put into maybe like a supplementary materials for your thesis or something like that?
It could be, or you could even write your thesis like this. Like
Okay.
this can be a whole document, and it's
Yeah.
also the kind of thing that can be submitted as a paper. Um, it's the kind of thing too, like you can, have this as like rather than you could share this Word document around and people could comment in it. You could use SharePoint for that, for example. Because look, not everyone's going to be cool with using R. So you can facilitate collaboration that way. You could upload it on SharePoint or, even Google Docs or whatever, and they can make the edits and you can change them. Or if you're working with someone else who's cool with R Markdown, they can go in and edit it too. So you can do collaborative kind of things. But what I see this being is the kind of thing where this can actually be submitted if it's all formatted correctly. So I'm going to talk about formatting in a sec,
Cool.
and where you can find little files that basically are templates for formatting. And we'll talk about referencing too. I'm not going to demo referencing because there's a bit to it, but it is very possible to reference in here in the appropriate formatting too. And you can reference based on pretty much any reference library. Like if someone's using EndNote, that's fine. If someone's using Zotero, that's fine. It doesn't link directly into your EndNote library. You export your library as a BibTeX file and you can have that here that you can draw on. So there's a lot that you can do here, but for me, this is something that I feel is a bit of a game changer in terms of particularly getting the data out of R. That's always the hard thing. So let me see. What else can we do? Let's talk about the code before we get into things like the formatting and all that kind of stuff. Okay. Now, can you read this code okay, or is it a bit small? It's a little bit small because I'm thinking what I might do is I might drop it into a Word document, which will kind of stuff up some of the stuff a little bit, but it's okay for demo. So we're going to lose some of the nice formatting here, like the green and all that kind of thing, but it'll give you a bit of a sense of what it is. Okay, so here's all the XML stuff at the top. This is the formatting of the document. What I really want you to see are every time we have a code block, there are these three, what do you call them? They've got it's not an inverted comma. It's the one that's on the top left key under the tilde, at least on my Mac keyboard, the one above tab. So rather than like a single inverted comma, it's that one that's on a bit of an angle. I'm sure it's got a name. I don't know what it is. But you use three of those things to start an R code block. Like this R says it's going to be R code. You can have comments in this to yourself, just like you would in any other R code. This is just R code everywhere we've seen. And you can use all exactly the same things, including loading packages and all of that kind of stuff here too. Okay. So that's how you actually do the code block with those three inverted commas. And then here is how you call stuff within a paragraph. You see there's one of those little inverted comma things there. All right. So the two stars around the T make it into italics. If we have a look at our document here, the T is in italics, and then there's an open bracket, and that's just here in the text. And then everything between the brackets, what we're doing is we're drawing on that R block, we're rounding the parameter from to 2 decimal places from the t-test. So it's that idea of pulling out a piece, a single piece of the t-test, and being able to insert that directly into our document rather than having to type it by hand each time. So, if you have to adjust your analysis, for example, let's say you go, I only wanted to do it on cars with 4 cylinders. For example, I don't know, you can filter this t-test down to 4 cylinders and all of this will update automatically. All right. You don't have to retype it every time. So really handy, particularly for those like we all have those papers where, you know, ideally we have pre-planned analysis plans and all that kind of thing. But let's face it, doesn't always work that way. All right. Or, you see something in the data and you're like, oh, that doesn't make a lot of sense. Oh, I thought about something. There's something I didn't think about in my pre-plan, So I really like this functionality here in terms of being able to pull stuff out of my results directly into a document and being able to share that. Even if you're not comfortable with making this your final submission document, it's the kind of thing that you can share easily with collaborators and stuff. And of course, you could make this into tables. Like you could have a table here where you draw on each of those, but there's easier ways to do tables. We'll touch on that a little bit. And here I am pulling out means. I'm going to round my mean to 2 decimal places. It's the mean of the MPG variable in MT cars, but only for cars where the automatic or manual equals 0, right? So this is the automatic cars. And then this one here is the mean for MPG, but only for when AM equals 1, which is the manual cars. Okay. So you can pull all of this stuff out straight out of your data and compare that to how most people do it. They'll run something in SPSS or Jamovi or whatever. And it's really hard to pull the data out into text like this. You end up typing it manually. And I don't know how many typos there are in papers from this kind of thing. It's a real concern. Whereas this allows for getting around that. So any questions around, why we might use this? And then let's talk about like improving things a little bit.
I was just going to say this. I think this would have been really handy to know. I don't know, about 3 months ago when I was doing 3 different multi-level regressions
Yeah.
and then trying to be like, okay, which one was this? Which one was this? It would have been just so much easier to put that in and be like, done with it.
Yeah. Yeah.
Rather
Yeah.
than going backwards and forth, like, which one was that? And yeah,
Yeah. No, exactly. So I
this is
agree.
cool.
Look, I think it's really good, but just like I said, particularly for that extraction stage that's so difficult. So that's what I sort of wanted to highlight here. Cool. So I'm glad you see the use of it. It's one of those like set it up well once kind of things. Like, there's a learning curve. Spend a little bit of time working out how it works. But once you get it, it'll be a lot easier. So that will be hopefully useful.
Krishna also asked in the chat, I don't know if you've
Oh,
got
sorry. Can we do the same in Jamovi? Actually, you know what? I'm not sure if there is R Markdown in Jamovi. I'm going to ask and let's find out. But remember, you can, no, it doesn't, but you can take your Jamovi output, you can link Jamovi and R, which is not part of this series of workshops at the moment, because it's a matter of like working out what we have time for. And also, we're going to run these going forward more, but this is the first time we're trialing them. But what you can do within Jamovi is you can actually generate R code to do your analyses in R. So you can set it all up in Jamovi, get that syntax out, and then run it in R and use R Markdown there. So if you're more comfortable with doing the analyses in Jamovi, do that. But then to do the R Markdown, you still have to go into R. But there's an easy transition from pulling out the code to do the analyses and doing that in R. All right. So let's, what I'll do is I will pop all of this code in the chat. It might not go all in one go. Well, it looks like it's worked okay. So you can have a copy of that for and try running it and play around with it by all means. All right. So that's one thing. Now, what I'll give you a second to just copy that code out of the chat. And hopefully like it doesn't stuff up the various, like, you know, how sometimes it formats like inverted commas and things like that into funny ways. Hopefully that doesn't stuff it up. You can see, of course, that there's going to be some issues around learning, you know, all right, an asterisk around a letter means that it's italics and those kind of things. But it's the kind of thing where there can be a bit of a cheat sheet. And I'm pretty sure that if we go into help and look at R Markdown, there'll be some stuff here too. Or there's plenty of cheat sheets online. So yeah, heaps of stuff here on using like Markdown and all sorts of other things here. Mark character strings and all these bits and pieces. So there's lots of stuff, but sometimes, you know, the challenge with these things is knowing what you need to ask. So there's lots of work demos on these. For me, the workshop here is not about showing you absolutely everything you can do. It's highlighting the ideas so that you can start to think about it and play around with it. Okay. All right, let's talk about citation or formatting styles, for example. Now, there's a very easy way to format our documents via like APA, for example. So I'm in psychology, I use APA formatting, but you might use anything else. And there's always things like heading styles and stuff like that that you need to consider. And again, typically, many of us do this in Word, right? We might download a Word template. We probably don't. Particularly students, we kind of go through and just go, all right, this is heading 1. So I'll do this. And God, what is it? It's got to be bold and left aligned and sentence case or something like that. You know, and you got to look it up every time because you don't remember. If you're smart, you might, and I'm smart, but I forget to do this every time. Actually, I'm not that smart, but you know, you get the idea. There are Word templates that you can download with different citation styles, but they're not always right either. You know how you choose styles in Word, like heading and stuff like that? They're not always right. So don't rely on them. However, for anyone who uses Zotero as like their reference library, and even if you don't, like this is just something that Zotero as a company has put out. Here are all these files where you can actually download a little template file and then call on that in R Markdown. So let's give that a go. So we're using APA 7th edition at the moment, for example, and that's here. This is specifically for citations and things too. So you can pull these things out and you can call on these in R. So when you download this, this is going to give you a little file which is called a CSL file. And you put that into your working folder here. So let me just stuff for the uni workshop 2. So this is my folder that I've got going at the moment. There's my R Markdown documents and things like that. So I can pull out this APA CSL file, which is what I've just downloaded. And these kind of things I can reference in the top of this XML thing up here. So CSL is apa.csl. And this is just referring to this file that I've popped in this folder. So what we can also do is if we have all of our references like exported into a BibTeX file. So let me have a look at doing that quickly. Didn't prepare this. Is this going to work? Let's find out. So I'm going to open Zotero, which is the one that I use. But if you're using EndNote or PaperPile or anything else, you can export them as BibTeX files. So you can select all of the references that you want to export, and you can export your library, like the whole thing, which might take time because I've got, I don't know how many thousands of references in here. But you can export it as a BibTeX file. So here we go. I want to export it as BibTeX. I want to export everything, and that will make this big file called a BibTeX file. And I want to save that in my working folder here. All right, the same folder that I'm using. So I'm going to call it, bibliography, and then hope I can spell bibliography because I'm going to have to spell it in my code in a sec. All right, so that's exporting a bibliography file here for me. And then here I can say my bibliography is bibliography.bib, all right, which again is referring to a file that I've just whacked in here, all right, which is coming. So it's here, and this just hasn't refreshed down the bottom here. There it is, bibliography.bib. So in my Markdown now, I've got my bibliography in there, and I've got my citation style. And then that means that I can start to insert references. And to do this, you just do things like, at, and then author and year. So you'll need to know how they're referenced in your bib file to actually call on them. But this is how you can actually do citations in R Markdown. It's a little fiddly at first, but once you get used to it, it's pretty handy. So, all of again, for a lot of people, doing citations is a pain. All right. A note taker thing. I gotta say, these note taker apps, it's a bit pushy. It's come up in the chat and it's gone, are we all done? I'll be leaving in 1 minute unless I hear someone talking. I've been talking. Right? I feel like I've been talking. Anyway, pushy little app. So, this is how you can do all your citations in here. But note that every time you start a new Markdown document, you're going to have to pop your bibliography and your CSL file into whatever working file folder that you're using there. Or if you want to, you can have these stored in like a central folder, and you can have a path to it here. That's pain. And note as well, though, if you update your Zotero library or EndNote library or whatever, you should re-export it here so that the updates are saved in this file. So this file won't update if you save stuff. The AI is gone. Good. It won't save things in your bib file here if you update it in EndNote or whatever, because this is a file that's just current right now. As soon as I change anything in Zotero, they're different again. So it's a little bit manual. There's no direct linking into your Zotero or EndNote library, but it's not that hard either, in terms of drawing stuff out. So R Markdown, I think that there's a lot of promise here. I think it's a matter of seeing the options and seeing what works. Any questions, concerns, thoughts, comments?
So to add the citation, it's just at and then
Name and year usually, yeah. But it gets tricky when you've got multiple citations by, Russell 2023 or whatever in there. So you do need to know how each one is referenced. But so that's why I haven't sort of demoed it here necessarily. But it's all doable. All right.
And so when this comes out into the Word document, then if you do put the citation in here, is it then a live citation in the Word document?
Let's see. Let's see if it works for a Russell 2023 one. I think it's not going to find it. Yeah. Yeah. It couldn't find that one because it doesn't know what this is. And it also had a problem with reading the file. So this is one of those fiddly little things where spend a little bit of time working it out, and you'll get it. I wasn't going to do it live, so I didn't prepare as much as I should have with this bit. And now I'm maybe I should have. But this is one of the things for R is you do get these error messages where you're like, what is that? And it's the kind of thing where you can actually drop it into, particularly Claude as an AI is very good for this to help you undo some issues there. Okay. All right, I'm going to finish on R Markdown there, just to highlight that I think that this is a big step up from pretty much any stats program like SPSS and Jamovi and others in terms of being able to actually write stuff in here, you know. So I quite like it. All right, let's close down the Markdown stuff. What am I going to do now? I'm going to show you something a little different now, which is I'm going to do two small little things here, and then we're going to play around with graphs. So one of the things I want to show you is doing text analysis, like sentiment analysis and things like that in R. And another one, or like, words, word associations, for example. And another thing I want to show you is scraping, like being able to scrape the web, for example. So other ways, things outside of normal stats analyses that we think of, where you just load a data set and that's it. Let's have a look at actually something a little different. So I've got a script here, which is text analysis. I'm pretty sure it's all working. So I'm going to grab all of that and drop it into the chat. It's not going to like it because it's too long, so I'm going to have to do it in bits. And what we're going to discover with this one is that there is a package, like an already made package in R, which has all of the works of Jane Austen. In it. And we're going to use that to actually do a text analysis of Pride and Prejudice. All right. So, and we're just going to showcase like some examples of what can be done. All right. So there's 3 bits to the code there. Like I've had to copy it over in chunks. So copy that out, pop it into a script file. So this is not Markdown anymore. We're back to scripts. Okay. And here, what we're going to do is we're going to load a package called Jane Austen R. All right, so it's all in there. And if you need, at the top of the code, I do have install packages Jane Austen R commented out. I'm almost certain that all of you will have to install this. So just, remember to install it. Just remove that little hash at the start. All right. And then that will load a package onto your computer which contains all the works of Jane Austen. I told you, there's loads of packages, all sorts of random stuff. And it's not just about functions and analyses. Sometimes it's about different types of data. And so keep in mind that you can do a similar thing with your data. You can make it available as packages for people to be easy, to make it easy to load. So, if you're writing a novel about, I don't know, what's Pride and Prejudice about? I don't know. Women stuff. I don't know. Back in the day, and you want to make it available in a highly technologically advanced, sort of place, then you can. All right. So remember, here we've got all these data sets and stuff like that and results and things in our environment from the last script that we were doing. So we don't want these. What we do want to do is to use this rm list equals ls command. And remember, this will clear out any unnecessary environment here. So it's always a good thing to do at the start of mucking around with stuff. I'm going to open these packages here. All right, load them into memory. And then what I'm going to do is I'm going to run this command here, which is going to bring in Pride and Prejudice. So we've created an object here called Pride _ Prejudice. And the function that we've used is Austen Books, which is to pull out the Austen Books command, to pull out books from the Austen Books library category. We're only pulling out the book called Pride and Prejudice, but we could do a bunch of others. We are going to add a thing called line, which refers to row number here. And there's some stuff here about unnesting tokens. So this is some code that's specific to that data extraction thing. So you don't need to necessarily worry about this too much. All right, so now what we're going to do from this is we're going to extract all the words in Pride and Prejudice, excluding words that we call stop words when we're doing a text analysis. So things like the and that kind of stuff where we don't actually like, I don't care how many times the word the appears in this book. It's not a word that I'm worried about. So these things are called stop words, and it's common to remove them during textual analysis. So I'm going to do that here. So we're making a version of this Pride and Prejudice words. There's 37,000 words now once we take out the and all that kind of thing. So 37,246 words are going to be considered in this text analysis. All right. Cool. So, and like having a look at some of the words that come through, there's a bunch of them like Pride and Prejudice and Jane and Austen and Darcy and Elizabeth and I don't know. So these are all going to be extracted, and then what we're going to do is we're going to play around with it. So the next thing we're going to do is we're going to create a thing called common words, and we're going to make a plot of it. And to do this, we're going to use a thing called ggplot, and we're going to explore ggplot more in the last half of the thing, but we're going to show you a little bit of it now. So the first thing we're going to do is we're going to explore common words in here based on the count of how many times that word appears. And we're going to sort them so that the most frequent ones appear first. Okay, so let's do this. We'll run all this. This has created a thing now called common words, and it's pulled out, we've told it to pull out the 20 most common words. Now, there's a little thing here as well that I haven't shown you before, which is this percentage sign, arrow, what is it? Greater than, less than sign, and a percentage again. This is a part of a thing called dplyr. So what this means is for command words, what we're going to do is we're going to do this thing. We're going to open the Pride and Prejudice words, and then within it, we're going to do the count, and then we're only going to take the top 20 of it. So this is a way of stringing together multiple commands into like a series to do all of them together. And it's a function of this dplyr package, and it's you don't see it outside of dplyr basically, but it's such a common thing to be used in R that a lot of people see it and know what we're talking about. All right, so when I do this, I've now created this thing called common words. It's got 20 observations and 2 variables in it. And the first observation is the actual word itself. And the second, like the first variable, sorry, I should say, is the word itself. And the second variable is how frequent it is. So we've created like a little object, a little data set, which is just the word and how many times it appears. All right, so that wasn't that hard. Like, think about all the times that you do like qual analysis and all that kind of thing, where you might want to do something like a word cloud or whatever and pull out like the most common words that appear. And you want to avoid all the stop words like the and all that kind of thing. It's such a common thing that happens that it's like, there's a tiny little bit of code here to do it. It's a little function in R. Someone's created it so that you can just do that same way every time. Then doing the count, it's 3 lines of code, and the code's not too hard either. So you can, just do that with your own data as well. All right, so now I've got a sense of what the common words are. Let's make a little plot. So of course you could do this in Excel, but here's how you do it using ggplot, right? Which is what we're going to, some of these graphs that are coming out now will seem a bit like, oh yeah, it's okay. But we're going to have a look at some really cool examples of plots in a little bit. Okay, so the way ggplot works is you specify the variables that you're going to use and the data set they're from, and then you say what type of graph you want. That's this geom command here. So this one's going to be a column graph. Then coordinate flip, that's just flipping my X and Y coordinates around. So notice how this code works. You do a command, and then you add a plus on the end, and then you modify it in some way. So here we say this is the type of graph I want. and then I do a plus, and then I modify it by like flipping things. I don't have to do this if I don't want to. And then I do a plus, and then I've got these labels. So my x-axis label is going to be the word, my y-axis label is going to be the count. Here's a title that I've put in there, and I can have a subtitle if I want, say excluding subwords. So this is how you adjust figures. And you'll find that over time you have a preferred style that you like your figures to look like. So like you can change the fonts that are used through commands like this, and you'll find that you set up a preferred style over time. And we'll have a look at some ways that you can modify this ggplot code in a little bit. But let's run this and get a sense of what this looks like. And here it is. So, here's the plot, like longer bars, obviously higher counts. So Elizabeth is the most common word in there, then Darcy, then Bennett, then Miss, Jane, Bingley, and so on, right? So it's all the characters because it's all about the characters and everything. Yeah, so it gives you a sense as well as like who's getting the most airtime here or the most screen time too, which is probably what you'd expect it to be. Okay. Cool. So that's kind of handy. That's like who's popping up the most. But now let's get a sense of a thing called sentiment analysis. So sentiment analysis is a thing where it's trying to work out, are they saying good things or bad things about stuff? So I've got the code here. First thing that we do is we do the actual sentiment analysis and we put that into a thing called pride, prejudice, sentiment. So you should have the code for this in your the chat there, or you can see it here on the screen, or if you're watching the recording, this will all be available in the workbook when I finish it, depending on what works here and everything. Okay, so I've run the sentiment analysis, okay, and here I've got a bunch of observations, and it's got things like positive sentiment and negative sentiment and things like that there too. So let's have a look at what this has actually done, and probably the easiest way to do this is to do the plot here. And so this is a column plot as well. And this gives you a sense of how positive and negative the sentiment is at different points in the book, based on locations in the book, right? So positive sentiment, these positive scores up here, like the book starts off all like, roses and sunshine and stuff. And then here's a little bit of conflict going on. Here's a bit of negative sentiment kind of going on. Here's some more positive stuff. And then here, there's a big section here where there's a bunch of negative sentiment going on. So I don't know, I assume they're like having a fight or something. Like, is there a sword fight in Pride and Prejudice? That'd be kind of interesting. No, I have no idea. But you could also see how you might use something like this to look at, say, sentiment over time, like with participants, for example. There's various ways that you can use this, but this is a quantitative text analysis. Couldn't find pivot wider. Have you loaded all of the things before? Have you
Yeah,
loaded
so
all of these packages?
loaded all the packages. I had to install Tidy Text,
Okay,
and
yes.
call it. So maybe try installing each by themselves.
Well, like see if they all run and everything. Hmm.
I'll get back to you.
Yeah, but also, again, perfect kind of code like to pop into Claude. So let's take this. Let's use this as an example of actually going to Claude and going, "Hey, fix this for me." So let's go to Claude. So which bit was it? It was this bit. Was it the actual plot? No, it was this
The
one.
one above, the analyze sentiment. Yeah, in that one.
All right. So you go, I'm trying to run this code, right? Drop the code in, and then you go, I get this error. Okay, and help. And then it's usually pretty good. It'll go, all right, need to load the tidyr package. Okay, so is that in my list? It's not in my list up here. So, all right, so that's a function that's specific in tidyr. So you need to whack that in the code up the top here. All right, which I've dropped in the chat there. So there you go, really useful. It's telling me here's what I need to run. If you run that now and then try running the code again, sentiment. So that's working okay for me. And then the plot works. That work better for you now? All right.
Yep.
So, like I said, Claude's very, very good at code here. And it's also really apologetic sometimes. It's like, you gave me this code and I'm getting this error. It's like, oh, I'm so sorry. Let me fix it up for you. It's really quite sweet. All right. So I really like Claude for code. I find ChatGPT is not so good for code, although the newer one, O1 or whatever, is much better. But for coding, I would recommend Claude. Okay, so this is looking good. Now, this is an interesting idea of what you can do with text analysis. And it's something, can you do this in SPSS? Can you do it in Jamovi? There's so many packages in R that can do all sorts of different things. All right, let's try something else. Let's have a look at like word associations. So here can we do this analysis with in-depth interview data? Absolutely. And so you can also flag code as coming from like different participants as well. And so you could, put in there details about them. Like, often when you interview people, they come from different groups. You might have people. So I work in gambling research. We might have people who are experiencing gambling harm. We might have people who are harmed by someone else's gambling. We might be comparing men and women. So you could have all that in your data there as well. And take that into account in your analyses here too. You could have a look at how sentiment differs, for example, by men and women. So again, the point of these workshops is to demo a bunch of functionality to get you thinking about how you can use it in your research, is the idea. Okay. And it's about the possibilities, right? Which I really like. There's so much that can be done. All right, let's do these bigrams. So let's talk about what a bigram is. We're going to do Pride, Prejudice, bigrams. And we're going to take these Austen books. We're going to filter all the words out of Pride and Prejudice. We're going to create. So what a bigram is it's like a combination of two words. So which words appear together or really close to each other is the idea, we will do that. We're filtering out stop words as well out of, so we're creating pairs of words here where words are separated only by a space. So the words have to be right next to each other. But you could have any separator there you like. Then in each of the list of words, we've got word one, whichever word comes first, and then word two, whichever word comes second. In each of the list of words here, we're going to filter out the stop words like the and all that kind of thing. And then we're going to create a count of each combination of word one and word two and pull out the top 15 of them. Okay, so this is about which words commonly go next to each other. And you can think, obviously, there's going to be some concerns about words being next to each other, and you might want proximity or something instead. There's lots of ways that you can play around with that. Again, it's just an example of what you could do. So I'll run this, and this creates now a thing called Pride, Prejudice, bigrams. And here we've got the first word and then the second word. So Lady and Catherine is a first bigram, and how many times that appears. Now, notice as well, this is also pulling out a bunch of examples where there's a space and no word either side of it. NAs, right? And actually, there's lots of these, like 2,500 of these. So if I run a graph with the bigram, the most common thing that's going to come out of these NAs, and I don't want that because that's not really telling me anything. And it's giving me a big bar here that makes all the rest look stupid. So I'm going to do a little filter here where I get rid of them. So see, here's my ggplot. Here's my filter, and I'm filtering out when any situation where word one equals NA and word two equals NA, which is this bar. Okay, so I'm doing that on the fly. I'm doing it in my graph command. Like I'm not redoing my analysis here. I'm not changing my bigram analysis. I could, but I can also do things on the fly when I'm just making my graph. And again, this is really something that sets SPSS R apart from other programs a bit. So I'll run this version with that filter in there. All right. And now here we go. Here are the common ones that go together. And it's always like the Mr. and the Sir and all that sort of thing. Here's one, cried Elizabeth. So, you might look at these and go, actually, some of these ones are not ones that I want either because I don't really care about their title. So I might filter out those ones too. But once I've done that, now I'm getting into the ones like, Elizabeth crying and stuff, which is more interesting or traumatic or whatever. So, using this to extract the information and then on the fly being able to filter the information is to me a bit of a game changer. I quite like it. Cool. Now, note here though, filtering it on the fly, I am only now getting 14 bars. And that's because earlier I said I only wanted 15 of them. And if I'm filtering it here, then I'm filtering from that 15, not from the initial thing. So it might be better. So like if I were to filter all these ones where there are like titles, like Lady and Miss and all that kind of thing, I'm going to lose like half of these, maybe more. And I'm only going to end up with like 5 or 7 bars or something. So it may be better to do the filtering at the data extraction stage rather than the graph stage in some instances. All right. Okay, so that's like a basic run through of sentiment analysis. Of course, you could take this a million different places and play around with it a lot, but I think it's a really useful thing and an example of what R can do that a lot of other software can't do, all because of those add-ons, right, through the packages. All right, any questions about sentiment analysis? Because next thing I'm going to show you is scraping data off the web. Cool. Okay. All right. So here is another script. So I'll go to my files and here's my scraping script, which is a terrible name for something. That's not my list command. I never remember it off the top of my head. So let me just go to here and pull it out. That's it. So close. All right, so we're going to do the rm list equals ls thing, and we're going to load some packages here. And what we're going to do is we're going to set up a little function and talk about what we're doing there. And we're going to pull some data off a web page. All right, and then from that web page, we'll be able to talk about what information is there. Now, this is an example of where I could use this kind of thing. So again, I work in gambling research. An example of where I could do it is scraping odds off betting websites, for example. Seeing what prices are being offered and scraping them as time goes on, for example. That's an example. I've done things like extracting data from Twitter, which did I show you a little bit of that last time? Like pulling data off Twitter. Some social media is better for this than others, like particularly more text-based stuff, like Instagram is a bit harder. But you can certainly extract data off various places there, which is quite handy. So this demonstration, though, what I really like about it is it's going to introduce you to this idea of making your own function. So all of those things that we've been doing, like the t-test function, for example, when you run that, it does a bunch of things in the background. Like it does all the t-test calculations for you because someone's programmed it that when you type t.test, it will do all the sums of squares and, and the comparisons and working out the p-values and all that kind of thing all in one go. But it's just a series of steps and someone's made a little function so you don't have to type it out each time. All right. So scraping data from a web page is the same sort of thing. You've got to open a page. You've actually got to open the HTML of the page. And then on the page, you've got to pull out some information like book titles, for example. So you then extract the book titles. And then if the prices are there, you extract those too and you make them into numbers. And then is it available? Is it in stock or not? And what else have we got? How it's rated, like how they have stars, like how good people think it is, for example. how many ones, how many twos, all those sorts of things, and then combining it all into its own little data set. So if I were doing this on a bunch of pages, every time I went to a new page, I would go through these steps. But I don't want to have to type them out every time, like all of these steps for every page that I go to. So instead, what I do is I create this thing called Scrape Books page, and it's a function. And the function is when I do this thing and specify the URL, like the website or web address of it, it will then go and do all these steps. It will open that web page, and then on that web page, it will extract the books, book titles, and then the prices, and then the availability. And I don't have to do this individually for every page. I just say, whenever I say this thing, Scrape Books page, and give it a URL, this is what it'll do for me. All right. So here's how we might use it, right? So here's my like if a thing has multiple pages as well, here's an alternate version of a function. But here we go. I want to scrape some books. I'm going to use my scrape books function, which this is the one for when there are 2 pages. So it'll go to the next page, like when you've got like 15 books or whatever loaded on the first page and to the next one. So I've created a function that can deal with that kind of website. All right. So I'm going to do that. I'm going to scrape the books, and then I'm going to do some plots. So let me run all this. I haven't put all this in the chat yet. So here's my first function. And hopefully you can see that you can take this and do this, like adjust this as you need to. Not too much. There's the 3rd bit of the code, and here's the 4th bit of the code. Okay, so what I'm going to do is I will first up, this has still got all my Pride and Prejudice kind of stuff up here. And I don't want that here. So I do my rm list equals ls thing, clear everything out. And then I'm going to load my packages. And then when I run this first function, all it's doing is it's creating this thing called a function. All right. And that means that becomes a command that I can draw on. Now, you'll find as well that over time, if you get quite good at this and you do repetitive things in R, like if you want to set up when I do a t-test, I want to get the means and the standard deviations for each group, and I want it output in a table that looks like this and everything. If that's how you want it done every time, set up a function, right? And then you just go, like you set it up so the function is looking for whatever DV and whatever IV you're going to put in there, and it will do the rest for you. So functions are probably and custom functions that you can write are probably the most powerful thing in R that there is. In fact, that's what everything is. All of these packages that we've been doing, they're all just custom functions that people have made. All right, I'll run this one for scraping from multiple pages. All right.
Can I just really quickly just double check?
Mhm.
So if I wanted to make for that, I can just really like the RM list kind of idea where you're starting a brand new thing and you want that, and then you want it to not be in different, you want every script to start with this particular set of functions. You could just make a function to create that.
Yep, and then you call on that. But R has to know where to find that function too.
Yeah. Okay.
So the other thing is there is another thing called the R environment file, which is similar to what you're talking about there. You can set it up so that R is always customized for you. That's okay. That doesn't travel well to other people's machines.
Yeah, that's true.
So what I typically have though is I will have an initial script that has loading data. You remember I talked about my steps. Load data and save it into an R data thing. Adjust your data, save it into an R data thing, then do your analyses.
Yep.
You can have a step in there, which is where you load functions too. So I usually load functions in the initial data acquisition thing too, and they will be saved into my R data object that I can then use. Yeah.
Yeah. Cool. Thank you.
It's all good. Good questions. Okay, so I have created two different versions of a function, one which only looks at the first page and then one which will go to page two, and you can tell it how many pages deep to go. So I'm going to use that second one and I'm going to scrape data from the first two pages of, there's a demo website that's set up for this. All right. The demo website that's using is this one, books to scrape.com/catalog/page. But you can set up the function so you enter the URL. So you might go to like Angus and Robertson. So like as an example, if you want to see how prices change over time, you could set this to go to a particular page, which is the search results page for books on weird shit in American politics, just to be topical, for example, right? Yeah. And so you make it so that, all right, so what happens to interest and ratings and prices on these things over time, for example? All right. So I now have scraped information from that demo web page, but you can use any other web page. And just a flag that some people make their web pages so that they're not so easy to scrape because they don't like want competitors like easily getting access to their prices and things. But this page has been set up so that I can. I'm going to load ggplot2 and I've now got this pricing data. I'm going to do an example of a plot. This one is the books by their rating and price. And this is a box plot. I've set the theme here. For those of you who attended the initial Jamovi workshop, I showed you some examples of themes. There's a bunch of examples of different types of themes that you can draw on here. We're going to use the minimal one, and I've got some labels. So I'm going to do a plot here, and let's run this. And here it is. So this is the average price based on the rating. All right. So books that are rated 1 have prices that like in this sort of range. It looks like books that are rated 3 here, tend to have like slightly like there's some higher prices here, but the average is a bit lower. 5-star ratings tend to be a bit lower in prices, presumably a demand thing. The more that they're selling, probably, the better discounts, bulk discounts people are getting and things. So it gives you a little bit of a sense of the data. Of course, this is maybe a bit weird. You probably want to have the ratings ordered along the bottom there as well. And you can play around with that too. So at the moment, this is coming out in alphabetical order rather than numerical order. But, these are all things that you can adjust. Now, what we want to do is we can save the data. So here's how you can output data into an Excel file. So I've written it into an Excel file here. And here it is. So this has created an Excel file with all the data that we just scraped. Like here's the name, here's the price, whether it's in stock or not, the rating, and some book IDs that we can use if we need to. So, that's how you can easily get your data out of R as well. So that's not too bad. What else have we got here? All right, let's have a look at a bit of a summary of what's going on. So here's like that summary of variables that we saw last time. So the title, right? There's no summaries like means or whatever of titles because these are just book names. So this is a character or like a string kind of thing. Price is numeric. Whether it's in stock or not is a character thing. So, if I wanted to do like a t-test or whatever, I might need to consider making these into factors, coding them as 1s and 2s. Same for ratings. At the moment, this is just words, and that's why that was coming out as numeric. Alphabetical order. So you might want to adjust these into numeric variables. And book ID, we're not worried about because it's just, this is book number 1, this is book number 2, All right, let's do some stuff. What else can we do? We can add some error handling in here. What about if there's some problems with actually scraping the page? I probably want a message telling me that. So this is, again, how you can add some stuff into the function to actually give you informative errors rather than the errors that R kind of spits out with where it's like nah, didn't like it, not going to tell you why, you got to work it out. Go and ask Claude. You can actually say, if it goes, I couldn't open the URL, then it's going to say, no, that URL didn't work for me. You can give yourself actual human error messages here. Again, just like nice examples, things to think about as you sort of go. What else have I got? Let's add a little more detail here. We're going to use tidyr for this. And let's have a look at some other ways of doing ratings. For example, like we can have a look at analysis based on whether they're in stock or not. Like, yeah, the ratings based on whether they're in stock. Like, are the good books tending to sell out, for example? Or word frequency in titles, so we can get into like sentiment analysis again. Like, what are the, well, not sentiment, like just what are the kind of things that are selling well? Guides, for example. Are there any common words that are in the bestsellers or highest rated, for example? So just a flag. Most of us consider dealing with data that are human data. We're dealing with issues where we get people to fill in a survey or take a questionnaire some other way or whatever for us, or attend an experiment. There's plenty of ways to get other types of data here to play around with too. Okay. All right, that's what I've got on scraping. Again, I want to show you text analysis and scraping as just something a little different because I want to highlight like just how much more you can do in R versus any other program. But let's finish up with some of the stuff that really makes people happy in R, which is like cool figures and things. Now, is this under code? No, it's not. It's under. Um, I thought I had another R file here. Where are you? Give me a second. I think it's in my other working folder. But I've got one more folder here, one more script that we're going to work through, which is showing you examples of like other cool graphs that we can do. Here it is. There we go, intro. It was just in a different folder. So this is playing around with a thing called ggplot2 to highlight like the different types of graphs that we can do. And these are just some. And there are whole books on this. And a lot of them are free. There's a lot of really free resources online there too. Most of us will be used to like pretty boring looking histograms or box plots and stuff like that. And you can do all that. And you can do the things like making them like pretty enough and different colors and all that. We'll play around with that. But also I want to show you that you can even incorporate like analysis lines, like analysis within the actual graph itself, like, incorporate a regression line and error bars, for example, into a figure. So we're going to play around with that. I'm going to start with this bit of code here. Okay, so this is loading everything. So again, clearing out my environment, loading out the data, and also the packages that I need to do it. And then there's just a little bit of a reminder here about playing around with different kinds of t-tests and things like that. But we don't necessarily need that here. Still, I'm going to run that just so it's all there. All right. So the way that we do figures in ggplot is it starts with ggplot, and then you specify usually a variable and then what you're going to do with it. Then you need to specify what type of figure you want. So you do a little plus, and then here we're going to do a histogram. All right, and I'll pull that down here. So I'll just pull this through without notes. All right, and now I think when I did this ran a little histogram that looks like this for me. And you can see like there's some nice things that have developed in R code over time. Like it'll actually show you what the color is going to be. And again, there's a ton of resources around that give you all the list of colors in R. You can ask for it here too. And you can easily do things do I want more lines? Maybe I'll make bin width equals 1 instead. Let's have a look at what that looks like. It's probably a bit too much. Those gaps, that's not that informative. That's a bit too much information. What if I go the other way? What if I make bin width equals to 3? Yeah, it's not too bad. It's probably somewhere around 2 or 3. So it's very easy to just quickly adjust and rerun your figures here. And if you want to save your figures, you can export them here too. So you can export them as an image or a PDF, or you can copy them to your clipboard. Or you can call on these directly in R Markdown if you want to. Okay, so that's the general concept of ggplot. You specify your variables, you specify the type of figure that you want, and that's this geom command, and there's a whole bunch of different ones of these. And then you can change all sorts of things. So let's add some labels to it here. So here's my code to add labels in. Because at the moment, this is saying like MPG and count, and that's not all that useful. So I'll add in some labels here. You know, count, I've just made it look a bit nicer. It's capital C there now. Miles per gallon down the bottom here, actually explaining what it is. Putting a figure, a title up the top there as well. So it's not too hard to play around with your labels and adjust these figures as you would like to. So any questions there about like basic ggplot functions before we move on? All right. Does it make sense? Have I gone too fast? No. Cool. And I want to see. There are also like a whole bunch of really good like cheat sheets on how to use ggplot. So like here's a bit of a kind of code sheet that you can kind of work on. And so this is from RStudio, which highlights like all the different things that you can play around with. And I'm going to show you some of these now. But if you want, there is actually this PDF, which is quite good, which highlights like different types of graphs that you can use, and situations where you might use them as well. Really handy sort of cheat sheets around too. I'm not entirely sure that this is written in English just because it's so nerdy. Um, but there's a lot of really good information in here. So again, I'll pop a link to that in the chat, and this will be in the workbook too. All right, so let's play around a little bit more. What about if we do a histogram like this, but I want to split it out a little bit to actually see which of these bars are cars with different numbers of cylinders. So remember in the data set we have 4, 6, and 8. So what I'm going to do is previously the fill was sky blue, right? So every bar was filled with sky blue. What I'm going to do now is I'm going to make it so that the fill is actually based on a variable, so that different levels in that variable will have different colors. So 4 cylinders will have a certain color, 6 cylinders will have a different one, 8 cylinders will have a different one again. So I'm kind of taking this idea and expanding it by saying, let me get a little more information out of the data. All right. So here's the code for it. And on this one as well, I'm also adding this theme minimal here too, just to make it look a little cleaner. So let's have a look at what this looks like. And this is also going to create a legend for me now as well, because we're going to have different colored bars. It's also got to work out how to deal with overlap. So there are going to be some of these bars where some of the cars in the bars are 4 cylinders and some are 6, and how it deals with that. So all of that is specified here. And again, you just get used to using the defaults on these are usually pretty smart, but they're there for you to play around with. You can adjust anything that you want. So I run this, and here we go. So now this is a similar kind of histogram, a little bit cleaner. That's that theme minimal thing that I've done there. And blue ones here, these are the 8-cylinder cars. So cars with 8 cylinders are getting far less miles per gallon because they've got more cylinders crunching through the fuel. And then it overlaps a bit here. Like, so some of these bars have some green in them, right? That's what I mean about the overlap. Like these bars are blue and green together. So here's like 6 cylinders is in this kind of place, and then 4 cylinders is up the top here. So this is telling me if I want more like miles per gallon, I want fewer cylinders here. All right. And it's a handy kind of visualization Where all we did was we just made it so that the fill color wasn't just one color for all of the cars, but it was based on the number of cylinders there. So this is one way of like, digging into the data a little bit more. And it's not a bad looking plot either, you know. Um, all right. So is that all right? Do you get the concept there? Because we're going to sort of take this and expand on it a little more as we go. Is that okay? All right, let's try a different type of plot. So here we're going to have a look at a bar plot. So instead of geome histogram, we're going to do geome bar. And that's because we're looking at cylinders, right? Which is a different type of variable. It's not continuous. It's not so much about like spread over a whole x-axis. We're talking about discrete values now for number of cylinders. So we're going to do this. We're going to fill it with a different color. Here we're going to use steel blue, which I feel like is something out of Zoolander. And then add our labels, and we're going to use the minimal title, minimal theme here too. So I'll run this, and here's a bar plot just showing the count, different numbers of cars for that we have with different numbers of cylinders in there. Okay, so like this plot is, you probably wouldn't put this in a paper or a thesis or something, but it's the kind of thing that you can do if you've got a variable where you've got more counts. Like this is similar to some of those word graphs that we were doing, based on like, the biograms, which one appeared the most and everything, but this one's just vertical rather than horizontal. Again, we can just flip that if we need to. So all we did here though was we changed geome histogram, which is, that histogram type thing like that, into a geome bar plot instead. Okay. And like as much as possible for the different types of plots, a lot of the same things will apply. Like I can set aesthetics, for example, across the different graphs, and the code to do that is very similar across them. All right, so ggplot bar graph. Cool. What about if I want to have a look at a scatter plot? Now, we use scatter plots quite a lot in terms of understanding relationships between usually two continuous variables. So here we've got a ggplot, and the type of graph that we're using is a geome point graph. I'm adding in some labels. I'm using the minimal theme, and we're going to take this and we're going to extend it a little more as we go, but we'll start with this. All right. So a scatter plot. Okay, I can see that the relationship between miles per gallon and horsepower is pretty clearly negative. Cars that have more horsepower have fewer miles per gallon. So that sort of looks all right, sort of what you'd expect. What about, though, if I want to actually include like an analysis line in there? What about if I want to include a regression line in there? And you'll see what I'm doing. So here's the code for it. All right, because this graph by itself, like, fine. But if we're using this to sort of describe the analysis that we're doing, then let's include the analysis. So within the call for the graph, I'm going to do my geome point thing that I've done to get my basic scatter plot. Then I'm going to do geome smooth, which is a line, a smoothed line that's based on an LM, which is a linear model. It's going to include standard error around a line. It's going to give us a regression line and include standard error around it. We're going to have a line color and some fill for the standard error here too. So this is going to be, the graph is actually going to be a 95% confidence interval around it. Then we've got our labels and our minimal theme. So let's run this, and now we get a plot just by adding in this regression line, which we're calling, like we're actually getting the analysis to happen in the call for the figure. Like we don't have to do the analysis and then try and plot that. So if I run it, I get my regression line through it with a confidence interval around it. And you can see like there's a lot more data here. There's a lot more confidence here. The confidence interval is a lot smaller. Down here, there's only a few data points and things. The confidence interval gets a lot fatter there. All right. And of course, this one at the moment is a linear model, so it's requiring it to be a straight line. You could have this being curved if you wanted to. You could do different types of lines here. So I'll often do these when I'm plotting data. Maybe I can show you an example of this from a paper. An example of where we've done this because it's a really nice example of how to stressful life events. Here we go. How to display a lot of data cleanly or hopefully in an informative way. So what this was a paper where we were looking at these plots. So this is the x-axis here is age. So starting at 18, that's when we started collecting data, up to whatever the maximum age we had in the data set. So this is actually retrospective, people looking back in their life to the age of 18. And the different colored lines, the full line is men and the dotted line is women. And the higher the line is, the higher probability of something happening to people of that gender, of that age. So this first one is work issues. Have you ever had work issues at any point in your life? This is a probability. So a lot of people say it, like men here, a bit more likely to say they had work issues around 25 or whatever than women. But then it's about the same. And then we start hitting retirement age and you start to have work issues here. Or here's one with legal issues, young men. I don't know how we survive young manhood. It's weird. We do dumb stuff, right? A lot more likely to have legal issues here compared to women. Although, young women still doing it as well, just not quite as good as the men in terms of getting in trouble with the law. Here's one, physical health issues, generally rising over time for women. Men, bit when they're younger, probably like, I don't know, snapping their knee playing sport and that kind of thing, or drunk shenanigans. Tails off and then picks up again. Mental health issues, higher for women all the way through, but generally declining. And also declining for men, but not quite as high. So you can see that like these are the same kind of figures with separate lines for the different genders. But with these, like here, I haven't restricted them to linear models. These show all the wiggles that happen through life, and it's really informative. And this was all done just within graphs, right? Like I didn't have to run all of these analyses, then plot them, then add the lines. Very, very simple to do. So I find this really powerful, and it really tells like quite a story when you realize what you can do with it. Because I think a lot of people would just go, oh God, I don't know how to do that, so I'm not going to do that. Okay. What about if we do a scatter plot and we want to do that thing where we show the dots being different colors based on the number of cylinders? So now we've got kind of three variables incorporated into it. We've got miles per gallon and we've got horsepower. So sort of same as what we have here, but now the dots are going to be different colors based on cylinders. Okay, so let's do this. And it's that similar scatter plot to what we saw before, but different colors for different numbers of cylinders. So more horsepower means more cylinders, but they're also the one who are chewing through all the petrol, getting fewer miles per gallon. So that's handy. And I mean, this is the kind of graph you can do in SPSS as well, but the next little graph isn't really something you can do in SPSS. So what about if we want to show that idea of the scatter plot, but with different regression lines for each group? So we take that same idea as what we did before, this scatter plot with the different colored dots. We add the geom smooth function to add those regression lines in, these linear models, but we're doing them separately for each of the different numbers of cylinders. So there's going to be three different regression lines in here. So I'll run this. And notice the regression line also restricts itself to where there are data for that number of cylinders. Yeah. So you can see for 8 cylinders here, it sort of doesn't matter how much horsepower it has. It's getting about the same miles per gallon. Like it drops a little bit, right? But not a lot. But here for the 4 cylinders, as the horsepower increases, there's a fairly clear decline in miles per gallon, right? So a nice way of visualizing things like interactions. Okay? And again, a really powerful figure because it also shows like the error bars and things like that there too, or the error areas to help you get a sense of just how reliable each of these analyses are. Okay. So any questions about that? Could you see it would be useful, even just for data exploration, even if you're not necessarily publishing this? But again, this is the kind of thing that can go into a paper. And the other thing I like is what I often find is that when people are using R for analyses and you start to see these figures, peer reviewers are kind of like, oh no, they know what they're doing. Don't criticize the stats. They know R. It's great. Right. So like R graphs have a certain look to them. Like it's quite clean, but it does sort of lead to that like, oh no, don't tell this guy what to do. He's fine. Okay. What about now? This figure is maybe not my favorite example of it, but what about if we wanted to do that kind of thing where we have panels? So that one that I just showed you from my paper, where there was one for work issues and then legal issues and mental health and physical health and all that kind of thing, those are called panels or facets. So what about if we wanted to do this and we wanted to split these rather than having them in the same figure? What about if we wanted to have like a graph? I'll just show you what it looks like. Where, so down here, like on the left here, this is 4 cylinders you see up the top with 0 for VS, which I can't remember what it is. There's only one car that has that, right? Then here's 6 cylinders for VS. There's only 2 cars that have that. But when we get to 8 cylinders, all of them have VS here, right? And none of them don't. Does probably have it. So it's splitting it out, like the data out, based on these other variables, number of cylinders and whatever the VS thing is, which I forgot. And then you could do this as well. So like, this could be split out by like age groups and gender, for example, and you can have a look at your data that way. And it's a way of exploring what's happening in individual groups in your data. And it's not hard. All you do is you take the graph, you've got your scatter plot here that we've set up before, and all you add in is this facet grid element. Okay. So we're defining how we split them out horizontally and how we split them out vertically here. All right, and everything else is the same. So you can see the ggplot language. You can see why it's really like people love it because it's not hard to change things to get what you want. It's just like here, this is a matter of like, I don't know, something like 16 characters, to go from this plot without the regression from this to actually splitting it out by cylinders and VS, whatever that is. All I had to do was add the facet grid and I get a different look on things there. It's a way of incorporating more variables, getting a more depth of understanding of your data. All right. And what about if we take that and we want to do a regression line for each of them? We just add our geom smooth in, and it's not going to try and do regression lines where there's 1 point because it's like that doesn't make any sense. And here there's only 2 points, so it's like I'm not going to give you error for that because like what are you going to do? There's only one way to get a straight line between 2. So it's kind of smart in the way it handles things too. But the rest of them look kind of similar to what we saw. All right. So again, I'm not like this is an example of where you can go too far by having like facets that don't that come out empty and stuff. Like that's kind of pointless. But it highlights the idea using this particular data set of here's how you do it by like age, like split age into 3 groups or something, or 4 or whatever. And then gender down here, you could have that as a way of splitting out your data and see what the results look like for each group. Or waves, if you're doing a multi-wave study, something like that. All right. What about adjusting labels and things like that too? So you can actually like adjust like the angle of the text or where it sits like horizontally and things. And I'll show you a real example of this in a sec.
Alex, could I get you to, is that the one that you just put in?
Oh, I might not have done the one with the regression lines, but it just
Yeah.
adds the GM smooth one. Sorry, there it is. There's the one with the regression line in it. It's just adding that GM smooth thing, right? I'm just trying to show you how all of these things can work together, right? Like you can do the colors, and then you can do the regression lines and all that sort of thing. So this example is just about like, sort of changing text as you need it. So here, like this is just rotated the X text like diagonally instead, 45 degrees. You could do that if you wanted to. I probably wouldn't in this plot, but it's an example of how you can do it. But let me show you a quick example of where you would do it. Oops, not that one. So I'm going to go to a direction that I don't want. I want to go to this one. So this is a graph which I will run and show you where I'm visualizing data by regions in the ACT. And see these figures here, like the text of them, right? If I don't adjust where they are, they just appear about in the middle of the region. And for the smaller ones, it just overwrites the regions. So what I've done is I've shifted them. Like I've used this thing like element text and I've horizontally adjusted it, right? Or more specifically, there's this one up here as well, where I've actually adjusted them based on like GPS coordinates and things. So I could do that because these were maps. But there's all the functions in here in terms of adjusting where text appears and whether you have data labels and all that kind of thing. It's really quite powerful. And again, it's the kind of thing where learn how you want your graphs set up and then just do that forever going forward. Yeah, sure. And again, you could set up a function. All right, so I'm back here. What else have I got? What about? I've got some other cool looking plots here. Where's the one that I just did? That was the one adjusting. All right, so you know how we had this histogram here before, which looked like this one with the different colors. Nope. Because I switched over, it has forgotten all the functions that I've got loaded.
I also didn't catch the script for the transparent histogram.
Okay, okay. Which is what, this one? That one?
That one. Yeah.
Okay. So you could have it looking like that, which is the script in the chat there now. Or like, histograms are all right, but it looks a little blocky. What about if we did it as a density figure instead? So let me show you what I mean by that. Here I'm going to use geom density. And this is a plot that I quite like. I just think this looks prettier. So let's run this. So instead of geom histogram, I'm using geom density. And it looks like that. Nice looking figure, right? I'm going to show you another one, which I really like, which is ridges in a sec. And this requires an additional add-on package, which we'll talk about in a moment. But see, I think that looks nicer, right? And particularly for when you got more data. Like here, there's only so much data, but when you've got like pretty big data sets and stuff, this works well. And I think more clearly shows the overlap than the histogram. And so this is where ggplot really comes into its own because a lot of people are going, how do I make pretty graphs? And this is what they've come up with. All right, here's another one. Now, I actually showed you this in Jamovi, which is a violin plot with jittered data. And so that is this one, where, here's an example of miles per gallon by number of cylinders, 4, 6, and 8. And each dot here is how many miles per gallon each one has. And all the dots are what we call jittered, where they're just a bit left and right over the 4 here. So they're not all overlapping with each other. Right? That's what the jitter means. But this gives you like a bit of a density, like how wide these are, but is based on how many dots there are. So here you see there's a bunch of blue dots here at around about 15 miles per gallon, and that's why this is wider at this point. Okay, so we saw a similar figure in Jamovi, but here it is in R with the R colors and everything. And so this is just called Geom Violin because it's called a violin plot because they often look like, the violin sort of thing. And then there's Geom Jitter, which is what's making those dots just not all be on a straight, like on that line for four. So it's quite common to do those. All right. What about if we did a scatter plot like we did before, but we made it? Let's say, okay, so we had that scatter plot. Let me just find the one that I'm talking about without the smooth. This one, right? So we had this scatter plot where it's different colors for different numbers of cylinders. But what about if we want to do, instead of being numbers of cylinders, we want it to be something continuous here, where colors might make less sense? Well, what we could do instead is we could make the sizes of the points change based on some continuous variable. Okay. So here we will adjust the bubble size. And I'll just drop this code in. All right. So rather than color, we're adjusting the size. And this is something that I use quite a bit. I find it really handy. So there you go. So this is based on we've got the colors based on number of cylinders, but we're also taking into account the weight of the cars here too. So you see the big 8-cylinder monsters, they tend to be heavier cars. They need more horsepower to push them. That's also part of why they go through more miles per gallon. All right. Whereas the 4-cylinder cars tend to be a bit smaller, and that's evident from smaller dots. So this comes in the scale size continuous little part of the code here. All right. So again, like learning all the different way. This workshop is not exhaustive. We're not going to get through all the different things you can do. I'm just trying to highlight some ideas so you can start to think about it. But you can see, I think one of the things that academics are really bad at is conveying data to each other. We put things in tables. We do pretty boring graphs, pretty rudimentary kind of graphs. What about if we could do something that's conveys a lot more information? And that's what I think I see here. What's another one? All right, here's one with a correlation matrix where we're going to do a heat map. All right. So remember before we were playing around with correlation matrices where we got it to extract the actual correlation numbers and number of stars and all that kind of thing. What about instead if we had a heat map that ran from blue to red with mid values? So like blue would be a correlation of -1 and red would be a correlation of +1. And then if it's in the middle, it'll be white, like sort of no color. It's got like a correlation of 0. Yeah. So we can do a correlation matrix between a bunch of different variables here. You might need to load a new package for that, Reshape 2, although I think we've used it before. And I'll run that. And I didn't like the X not being numeric, so I do have. So there's an issue there because we've sort of played around with the data a little bit. And I've got an example down here where I fixed that. Is it this one? Let me run through a few more because I think I'm going to get to a version where I fix that. All right, let's try a different one. A bar plot, a polar bar plot. So this is like that bar plot for cylinders, but it's round. People might like that. So you can have round graphs like that if you want. So the higher it is, the more there are. It's just the same as that bar plot that we did before. It's just round. That's all. Some people like that. That's the kind of thing that looks really good in something like a government report rather than like an academic report. This next one is I'm just going to run through the rest here now because we're running out of time. This next one, like I showed that nice density one rather than the histograms. What about if we want to split them out like this? So they're not overlapping with each other. They're kind of vertically jittered. That kind of works all right. And I've seen versions of these where they're a bit more like 3D, and I might have one coming up. All right. The next one we're going to do is we're going to add a new package, and you'll see that there's actually a lot of packages that start with GG. So people are taking the ggplot language that we use around how we set up our graphs and extending it and adding their own versions. So here we use one called GG Ali. And here we can show like, so what this one is, it's kind of an ugly graph, but what this one is here are different variables like miles per gallon and disp is, can't remember, horsepower, and various other variables here, weight and all that. And so you can see like the blue ones, which are the 8 cylinders, tend to be higher for DISP, which I assume has something to do with like weight. Horsepower tends to be higher for weight, whereas red ones, 4 cylinders, tend to be higher for miles per gallon, tends to be higher for drat. It's a way of like holistically visualizing data. And you can make this better by like ordering, what's on this axis here. But it's a bit of a way of like getting a bit of a sense of what's happening across multiple variables. Um, it's a messy graph. It's not a graph that necessarily everyone's going to be like, oh yeah, I get it straight away. It can take some explaining. So you might find it handy for your own stuff. But again, just an example of something where people have come up with ideas. All right, what about, so I actually created all these last night and I've kind of forgotten what they are. So here is like a bubble plot, but with labels, like drawing labels out of the data, like which car's which. And you can see this is an example where like I probably don't want yellow text because it's unreadable. So I'll take this and adjust it. Or I don't want the text overlapping the dots because I can't read it. So I might jitter them out a little bit. So again, this is just a bit of a starting point, but adding more information into the plot here, and what you can do with that. What's another one? Violin plot with jittered points I've already done. Faceted density ridges. I think this is the cool one I was looking for. So that's this. All right. So I'll run this and then I'll also show you a common little R issue that pops up. There's my faceted gradient density ridges. That's pretty. Yeah. So you see like, extending from that early basic stuff we did into, hey, check this out. Mum, look what I can do. It's kind of fun. Now, I do want to highlight an issue here as well that does happen sometimes. You see how there's like a little close bracket just on its own here? What often happens, and I did this a lot early on with R, is I select all of this and accidentally forget this little close bracket. If I run it, it kind of tries to run it, but then it's like, hang on, and it hasn't done anything. And you're like, ah, why isn't it working? And if you have a look, the console down here is, it's got a plus sign here, which means it's still expecting more. All right. So it knows that it hasn't closed all the brackets. So you can just run that little bit by itself and it will usually go, nah. So you just got to go back and select the whole thing and run it. And there's my nice plot. Okay. Cool. I like that plot. What about a circular bar plot with customization? This is this circular bar plot that we played around with before. And what about if we make it look a little bit different? It doesn't want to run anymore. All right, let me just try the next one, see if this one's working. Oh, sorry, because I've just set up, sorry, that was just a thing where I just ran a little bit of code to set up a new variable, of course. There we go. There's the whole code that I need to run. So I've just created a little variable and I hadn't actually run the graph, which is why it's not running. Here we go. That idea of the cylinder plot, but now I'm sort of the circular plot, separating them out. Again, I would move this text so it's not overlapping the bars, but this is showing two things. It's showing how many cars you've got with each number of cylinders. That's how far out the thing comes, and then miles per gallon for each one on average. What's another one? All right, so this is the one, this is my correlation matrix. But the problem was before, because we'd played around with some variables, they weren't numeric anymore. They were factor now. And so the correlation was like, I don't know what to do with that. So we're just reloading the initial data here. Everything is numeric. And this will run a correlation matrix for us and do a heat map, which looks like this. Now you could choose different colors here by all means. But yellow is a very high correlation and down to purple is a very low correlation. So again, I'm not sure I really like these colors. I would probably use something else. At the moment, this is using a pre-built scale fill called Viridis. But I would probably use those ones before, like red and blue. I'll see if I can pull those down very quickly. And this should work. So I want to get rid of that little bit here. All right, so let's try this again and see if this works for me. There you go. And this is showing the diagonal, so I'd probably get rid of the diagonal out of there. But you can see like more red values, and like the more red they are, the higher the correlation between them, higher the positive correlation between them, and the more blue they are or purple they are here. This reckons blue, but this looks purple to me. The more closer they are to -1, like stronger negative correlations. So often in these figures, some nice patterns can emerge that can help you sort of see what's going on between your variables in your whole data set. All right, and I think that's sort of all I want to show, and we're sort of right on time. So again, just to highlight that there's loads and loads of ways to play around with this. You can choose colors, you can choose fonts, you can choose different visualization types, you can customize anything you want. And in particular, it's a really nice way to get into like your own custom visualization and language so that when people look at stuff, they're like, oh, hey, that's Alex. He did that one. Because there's so much customization here, you can set it up however you'd like. There's also a whole bunch of people who actually use the visualizations in R to make art as well. So you can play around and actually do that sort of thing too. Just in case you've got any spare time on your hands, and when you have spare time on your hands, you want to sit in front of a computer. But that's the end of these workshops. So we've covered quite a bit. We've done a lot. We sort of started off by talking about Jamovi and how there's an option there for a free point and click program that's very easy, that updates automatically as you adjust your code or data, and all sorts of things there, and how it's built on R. And there's a lot of cool things about that. And now, hopefully, you understand a lot more about R. You can see the benefits of that. Then we moved into actually using R, and the basics of how it works, like opening, data and loading packages, and this idea of creating these object things that you can then pull functions out of, basic plotting and everything. We did quite a bit last week. And then this week, we've sort of taken it a bit further and shown you just some of the things that R can do, something a bit different, as pure examples. These are not the limits of what R can do. They're just some really different examples on the kind of stuff you can do. So started off by just reminding you a bit about like opening stuff, moving into this thing called R Markdown, which is where you can play around with actually making documents and calling on your data and analysis live in a document. And then into what else did we do? We did the text analysis, we did the web scraping, and just examples of what visualization can look like here too. So I think it's really powerful. I think it's really useful. I think there's a really steep learning curve to it, but it's also one of those things where once you get into the flow of how it works, there are so many more options available to you, and it might open up some research opportunities that you'd never really thought of. So that's what I got. Any questions, thoughts, concerns, complaints? No, all good. Alrighty. Let's wrap it up. I will get the workbooks out. I want to finalize those before I get them out to everyone, and add some commentary in around them based on today. Any thoughts about what worked, or in particular, was there anything here which should be dropped as a thought?
I don't think so. I don't. I really enjoyed all of it. It's really cool to see all the different graphs, particularly. Um, I don't know whether it's worth making comment on. I guess it's kind of a personal thing, but what graphs work best with what kind of data? Oh, see, that's the book I need.
There's a really good book. It's pretty cheap, and I think a lot of this is online here as well. So this is all in R, and it shows some examples of a bunch of different types of plots. It doesn't like it gets a lot of these are like some of the more boring kind of plots, but it does get into some cool stuff later, like maps, for example, like similar to what I've been doing,
Yeah.
um, which I didn't necessarily get from here. The other thing is there are a lot of R like learning communities. So like LinkedIn, there's a guy on there called Matt Dancho, Dancho. Um, I'm not sure I like his stuff so much because he tries to sign you up and sell you on stuff all the time. Like, it's a commercial thing. Um, but, he has emails that come out each day and at least give you ideas. So just, have a look at that, but be resistant to the push to spend money.
Mm.
But also, like I said, there's a lot of people on here who do some stuff, like all over the internet who use that. It's a really big user community. Um, I would be mindful that like a lot of the code that people use sometimes, like they've gotten to the point where their code is so efficient that you look at it and you're like, I don't even know what that's doing. Uh,
Mm.
because it's not apparent. So like I do work with some people sometimes where I look at their code and I'm like, I don't know what that is. Um, so there are challenges like that too. But have a look at a lot of those communities around ideas, and you'll see some really cool stuff pop up. So that would be a starting place. Yeah, but yeah, play around. And have a look at some of those cheat sheets which outline some of the different geome options and stuff like that. Or look at the help, and also look for packages that start with GG because there are all these specific ones that pop up for different plotting and stuff. So they're also good places to look.
Yeah.
Cool.
Oh, thank you.
That's all good. All right, let's call it. Everyone go and get a coffee, and I'll catch you around. Thanks for coming along.
Thanks so much for having all of these workshops.
Hey, that's all good. And big thanks to Tanya, Signal DDR HMS for putting it together, and Grace for helping facilitate it all as well. So there's lots of good things here, I think. All right, let's call it. Talk to you all soon.